Hello everyone. So I'm Alexandre Morin from Noveltis. Let me just share my screen and I will be presenting you a Jupyter notebook tutorial. So using Python as a programming language. I think you should be able to see my screen now.
Yeah, it's okay.
Okay, perfect. Okay, so I'm going to present you a case study about a hurricane because the topic will be coastal interactions and storm surges and the impacts of a hurricane on the coast. So the main topic here will be the Helene hurricane, which happened in September 2024 in the coast of Florida in the United States. So of course, events like these are extreme and have a lot of impacts on the coast, whether it's about ecosystems, human activities, or even human lives. And so we will see how it is possible to monitor these kinds of events and their impacts. So this is what we're going to see in this notebook. So here you will see that we use quite a number of Python libraries. All of them are pre-installed in the WEkEO lab kernel. So if you're working on the WEkEO Jupyter Hub, if you make sure to load this kernel in your Jupyter notebook, you will be able to import all of these. So we're using NumPy, which is quite common in Python to process arrays of data. Xarray is also very common in Python to process netcdf data, which is a format that is widely used for scientific data, which is what we're using in this notebook. Matplotlib and Cartopy are used to draw maps, and GeoPandas and Rasterio are used to to plot and to process geographical data. GeoPandas is for vector data, and Rasterio is for raster data. So, for example, satellite images. So, as I said, with this WeekLab kernel, you can import all of these. And now we're going to use a wind product to monitor the hurricane. So this is a brief presentation of the product. So it's a combination of satellite observations and model. So if you click on this, you will be redirected to the dedicated WEkEO page. So it's loading, but the information about the product should appear. It's taking some time. I'm not sure why. Anyway, and there is also the dedicated page on the Copernicus website if you want to have access to all the detailed documentation. So this wind data is hourly data, which is useful to monitor such events because they happen in the span of a few hours. And in this cell, in this section, I will show you how to retrieve the data using Python, and which David mentioned earlier. We'll be using the WEkEO API, which is called the Harmonized Data Access, HDA. So to use it, you need to have a HDARC file in your directory in Jupyter Hub. And if you don't already have it, you have to execute this cell, and it will create this file in your home directory and ask you to enter your username and password for WEkEO. They will be stored in the file, and it will allow you to have access to the WEkEO catalog through Python. So for me, I already have it, so executing the cell is not doing anything. And now I will show you how to download the wind data using this API. So basically, as David showed you earlier, so you can open the dataset in WEkEO, in the WEkEO data viewer, draw an area of interest like I've done here around Florida, because this is what we're studying. And when you want to download your dataset, you can just copy the bounding box coordinates to have to draw your area of interest in the download page. Select the variable that you need. So here we are using eastward wind and northward wind. Here is your start and end dates of your data. So in our case, we'll just be using September 2024. And when you click on Show API Requests, you have all the information that you've just entered as a dictionary in this format. And you can just copy and paste this in the text file here. So here I've copied it here. So this is my request, save as a JSON file. And so as you can see, it's in the data atmosphere request.json. And you can load it as a data variable, and using the HDA client library, you can use this data to search the WEkEO catalog. So here, for example, you can see that after the search has been complete, uh, it, the API found one match. So this is the file I'm looking for. You can see its size here. And if you uncomment this line, you will be able to download it on the path on the directory that you have chosen. So I've downloaded the file. It is here. And we're just going to take a look at it and do some processing and manipulations. So when I'm opening the data, you can see that using Xarray, I have a 3D data set that has latitude and longitude coordinates, and also time coordinates, because we have several dates available in the data set. We have downloaded data for a few dates in September, so you can see that it goes from the 20th of September to here the 1st of October, which is the time frame where the hurricane happened in Florida. And here are our main variables. We just using the eastward component and the northward component of the wind. So you can see that it's here. You have some more information, the units in meter per second, the minimum and maximum values, etc. So here are a few basic manipulations that you can do to subset the data, which is something that you commonly do when processing data with Python. So here you can just select one of the variables, for example, here time. And if you want to select several, target specific dates in your data, you can use the cell method. So here, if you know the exact date that you want that is in the dataset, you can just use cell time equal and write the exact date that you want to select. If you're not sure of the dates that are available in the dataset and you want to find a date that is not far from what you've chosen, you can add the nearest method so that it selects one date that is available in the dataset that is the closest to what you have written here. And if you want to select based on the index, so here, for example, I'm selecting the fourth value because the indexes go from 0 of the dataset. You can use the iCell method. And finally, if you want to select a data range, so several dates at once, you can add the slice function here, and it will select all the dates between those two. And you can see here in the results that it indeed goes from the 23rd of September, as I've selected here, to the 30th of September. Okay, so we have eastward and northward components of the wind, and what we can do now with this is to draw the vector field of the wind in the area. So basically, here I'm just computing the total wind speed for each pixel, which is well a simple calculation using the square root of the sum of the squares of the two components. So you can simply specify a new variable by doing by writing it, hiding it on the dataset this way, and you can see that now we have the total wind speed in the dataset. And now using these three variables, we can draw the vector field of the wind, so showing the direction of the wind and the speed using the color of the pixels. And this is what is done on this cell, just drawing the map. And this is the result that we obtain after drawing the wind vector field. So the arrows are drawn using the eastward and northward components, and the pixels are colored using the total wind speed that we have just calculated. And you can see that we can clearly observe here the hurricane happening because we have the arrow circling around here at this point that has a much higher wind speed than the other areas in this region. So we can clearly see the eye of the hurricane. So this is just a single static image. What we can do now is to plot the same plot at several dates in order to have an animation and see the trajectory of the hurricane. So to do this, we're going to repeat this operation on several dates. So we're going to target here a little more only the 3 days where the hurricane was visible in this area. And we're plotting exactly the same map, just not the arrows because otherwise it's not readable. And saving all of these images in a single folder, which in our case is here. It takes some time to execute, so I've already done it in advance. And now what we can do is gather all these images to build an animated image, sorry. And if we display it, we can clearly see the hurricane happening and where it strikes the coast of Florida. Okay, so as I've mentioned in the introduction, so such hurricanes trigger storm surges, which is a brutal rise of the sea level near the coast, which can cause, of course, floodings and damages to the coasts. So we'll try to highlight that using in situ measurements. So the coast of Florida has plenty of tide gauges that measure sea levels. You can retrieve such data in the American National Oceanographic Institute. So you can see that the storm hit Florida in this area, and we have several tide gauges that we can select. So as an example, we'll be using this one, which, if I'm correct, is the one from Cedar Key, which is here. So we've downloaded the data and retrieved it here. So when with in-situ data, you need to do some pre-processing to be able to use it with Python. For example, here we can see that we have a date and a time column in the dataset. To be able to process it as a date time compatible with Python, we just have to do this small conversion here, and now we have a date time in a format that is processable by Python. And here is the plot of the data. So we can see that this is the location of the tide gauge. And the predicted data is obtained from a model, and the verified data is the actual observation. And we can see that here the sea level is extremely higher than what was predicted from the model because of the hurricane. So this is a clear example of a storm surge. And in the next cells, we have just retrieved other datasets from other locations on this coast to see the magnitude of the storm surge depending on. Oh, okay. For some reason, it didn't plot everything. Perhaps it's because I haven't executed everything. Okay, so I just had to execute all the cells, so all the variables are active. And here are other tight gauges locations with their names here, so their key, Panama City, etc., and the associated storm surges that is visible for all of them. But stellar key, the first one that we have observed in red here, is still the highest storm surge that we have been able to observe among those tide gauges. Okay, so in the final section, I will show you some satellite image processing, and by that we are going to see to monitor the impacts on the coast after the hurricane. So for this, we will be using Sentinel-2 images that you can also download through the WEkEO catalog. And same thing as before, I've written two API requests in the data folder here. The requests are here, so you can open them and see what they look like. So basically, I've just in a request written for each time the identifier of the image that I want to download. So I've sort of searched for the image before writing my request. And so using this cell, you will be able to download them. So here you can see that here is a location that I am observing with my Sentinel-2 images. So I've selected two of them. One from here you can see the 22nd of September, so before the storm, and one from the 2nd of October, so very soon after the storm. And both are focused on this area, which I will zoom in later on, which is very near Sedarki, which we have just seen earlier, that it had the highest storm surge. So here's a reminder of the spectral bands available in Sentinel-2. So we'll be using those four here, especially the green and the near infrared ones. They have a 10-meter resolution, which is quite suitable for what we're going to do here. So here we open all of them individually using the Rasterio library. And here it's just a brief visual comparison of the two images. So one from September and the one from October. And here, looking from far away, we can already see that here the estuaries, for example, are much more flooded in October after the storm than in September. Also here, this river here is larger in October, which suggests that the area has been flooded in between those two dates. So to have a more obvious visualization, we're going to compute the normalized difference water index for both images. So basically, it's the normalized difference between the green band, band number 3, and the near infrared band, band number 8. And so it's a very strong water indicator commonly used for other applications in remote sensing, like agriculture, for example, but also flood monitoring. So basically, here are the two water masks here. And if we subtract them, if we threshold and subtract them, we will be able to highlight the areas that have been flooded because of the storm. And it is highlighted here. And you can see that indeed, the river that I've had noticed before has a lot of flooded areas between the two images. You can see this estuary here also. This beach here also has been a lot more flooded, and some patches here near the city of Horseshoe Beach. We have two patches here, but those are due to the clouds in the image. This is often a problem with satellite images. We can't really, we don't have control of whether there are clouds or not on the image. But this is a strong indicator of the impacts of the storm on this coastal area that is indeed inhabited now. So I'm reaching the end of this presentation. So if you do this exercise by yourself, you will see that you have a few more exercises that you can do to go further in this analysis. You can try to perform the same thing on other areas, study other hurricanes, etc. So you can use these tools to do this. And now, thank you. I'm going to thank you for your attention, and I hope that you enjoy this presentation. And I will be happy to answer your questions. Thank you very much.
Thanks a lot, Alexandre, for the nice presentations. I hope everyone enjoyed it. So we have nice feedback on the chat. So
Thank you.
so I go to the question. So the first question. So actually for this one, so I tried to download, but here's what I get: an error occurred. So I think there is a maintenance on some of the products today. So it should work again maybe in a few days, but normally for some of the data you can still download them even if you have this error. So try to have a look, but either way the data of the tutorials are already pre-downloaded, so you should be able to run the tutorial. So this question. So nice presentation. How can we remove the cloud cover before processing the data? Can we do that easily?
I don't think we can do that easily. I know that Sentinel-2, for example, because that's what I'm most familiar with, has a data set that tries to identify the different type of pixels that are present, and there is a cloud class that you can use to filter the data. But yeah, it's one of the most common troubles with satellite images is that you have to spend time to choose an image that has little to no clouds, which, depending on the region, is not always easy.
Thanks a lot. So this question, do you think we could apply the same approach to other areas?
Yes, naturally. This is well, an exercise that I've proposed at the end of the notebook. Um, I mean, for this particular analysis, there are some databases of recent storm and such that you can research from. WEkEO has a dataset that cover the whole world, so you should be able to find data on the area that you're interested in.
Thanks a lot. This question. Hi. So, will it be available in the future, the possibility to work with the data online without the need of downloading them? Good question. I don't think. Not yet, at least.
Future
But
update of WEkEO.
yeah, maybe we can submit that to the developers. But yeah, for now we can. We can't. Okay, wait. Lots of questions coming in. At this one, can we use shapefile to download the data?
I assume you're referring to a shapefile to use as an area of interest, maybe?
Probably. That's what I have in mind when I read shapefile. I don't know if we can do that on the WEkEO viewer to try to have an exact area. I don't know if David is still in line.
Not sure.
Okay, I will keep the question on the side.
Okay.
So we have a lot of questions. I'm going to try to publish them all on the screen. Okay, so lots of questions are about how to how to open the Jupyter notebook in the kernel, which kernel to use, and what we have to download exactly. So when you download the Jupyter notebook tutorial, you have a README file provided with it that explains all of the steps you need to do, where to move the folders, where to find the data, and how to how to run the full tutorial actually. So you can check the README, and then if you still have any question, you can contact the user support. They will detail everything to you. But you have also the full demonstration video available on the webpage of the event, so you can also have a look at that if you want, and you will have the replays to indicate you everything. No worries. Okay, so I also have a feedback on David on the shapefile question. So for now, it's not possible to upload a shapefile on the WEkEO viewer to download an area of interest. Okay. So this question: any provision to download Python code and execute the similar task in Python software offline? I think the tutorial one run also on your own computer, if I'm not mistaken.
Yes, it should work. I mean, you just have to make sure you have the necessary libraries installed, but if you have your personal notebook executor, I think you shouldn't have a problem executing the notebooks locally.
Okay, great. Thanks. So yeah, you can try and just check you have everything you need to run it. Okay. Next question. Which one is better between Jupyter and Google Earth Engine for image processing?
I mean, the two complete quite different tasks. I mean, I use Earth Engine sometimes, and it's great for visualization, for quick visualization and quick processings. I think if you want to perform more complex operations and go deeper in the analysis and associate with other datasets, Jupyter will be necessary. But yes, Earth Engine is very practical when it comes to visualizing areas and computing quick, for example, water mask or vegetation masks. But in my experience, for more complex operations, I usually switch to Jupyter.
Thanks. Still a question about Jupyter and Google Earth. Can we use the data from Jupyter to overlay it in Google Earth? Can we overlay, let's say, a file in Google Earth? I don't know.
I don't know.
No? Okay. Well, we'll have to look into that, but you have to taste it, but okay, so for the question about the tutorials, I think we're good. I don't see any more coming. Okay, so yeah, thanks a lot, Alexandre, for your presentation and the Q&A session. It was really interesting, and I
Thank
hope
you very
people
much.
will enjoy doing the tutorial